Welcome back to the garage, everybody. We've got one video for our two task sheets tonight. Our first task sheet, which is 387 on service history. There's not really a whole lot we can do with that, and you may have come across this task sheet before in the past, but what I want you to do is give me a little bit of history on your vehicle, whatever your personal vehicle is that you drive. Just, give me a little bit of background on it, some things maybe that's been done to it in the past. And then down towards the bottom, if you got some extra space, I'd like you guys to let me know why you think checking a vehicle's service history is going to be important for you going forward. It's something that I think is pretty important and that I always made sure that I did. So just let me know your thoughts on that down towards the bottom of the task sheet where you have a little bit of space. So for our second task sheet, 960, this is on spark plugs and secondary ignition components. So as we work through this sheet, it's going to ask for some specs. I know you guys don't have access to all data at the moment, but I pulled some things up. I wasn't able to find specifications for everything, but I got kind of enough to get us to work through this worksheet. So first it asks for some specs. Let's see. So for our secondary side of our ignition coil, it asks for a resistance spec on that. That's going to be between 3,000 and 7,000 ohms. It doesn't give us any kind of specification on the primary side. I looked and couldn't find it. I don't remember having come across that in the past. So it's just something they may not give out, and it may depend on the manufacturer. If you pull up something different, they may give you that information, but General Motors does not. And since that's what we're working on today, we're going to do what we can with what we got. Our spark plug gap is 40 thousandths of an inch, so we can check that here in a minute. It's asking for wires. Our spec for our wires is 30,000 ohms or under. I know sometimes I've looked in the past, and instead of giving you, a spec like that, they'll give you a little bit closer of a range, and a lot of times they'll give you a resistance spec along with a measurement, and it will be however many thousands of ohms per foot of wire. So you kind of got to do a little bit of math. It just depends on what kind of wires you have. If you have an older system, you may have some pretty long spark plug wires, so it just depends on how long they are. But let's, what we're going to do, I found a document on testing our ignition coil so we can test our secondary side of our ignition coil. I pulled this off of my truck earlier. We can measure the secondary side, and the other spec they give you, or the other measurement they want to give you, they're calling the secondary shield to ground. So that's another thing that they ask you to measure, which is going to be the same pin that we use to measure off of, and just going to the ground, going out to the bracket on this. And it actually tells you to remove a little bit of paint on this bracket so that you can get a good reading. So I took a little file and took a little paint off this so we can get an accurate reading. One thing I don't know if you guys have seen before or anybody else has talked about before, but when you're doing electrical testing, I have these little terminals that really make this stuff pretty easy. And you don't have to worry about damaging anything, especially if you're on a connector side. It's actual little pins like you would find on the vehicle. There's both sides, the male and female side. So when we're testing this, I've got these out there, and they've got these little plugs that you can stick in the end. And they're actually pretty cool if you're trying to do some electrical testing. You can actually make little jumpers out of them. So if you need to get in there, instead of trying to back probe or pierce a wire, if you have a small enough connector, you can just kind of put these in the middle there, and you can test off of these little brass pieces. So that's pretty cool. I think I got them off the Matco truck, but a lot of tool vendors carry these things nowadays. So these are definitely good. If you're probing around on the harness side of a vehicle, you don't have to worry about bending any terminals or anything. So they definitely come in handy. But what we're gonna do, I got my meter here. I don't know if you guys can see this on the video or not, but I got it set up for measuring ohms. So we are going to put this according to my document on this first pin in here. So I'm gonna slide that right over that terminal in there. I'm gonna hook up one of my leads, and then our other lead is going to go to our output, where we're going to hook up our spark plug wire. So if you guys can see the meter, we're reading right about 5,000 ohms. So our spec on this is between 3,000 and 7,000 ohms, so we are right in the middle. So I would call that a good secondary side of this circuit. I know we can't check the primary side. If it asks for primary side measurements or specs, just put NA in there. But if we're doing the second part that all data suggests measuring this ground shield, we'll touch that off to our bracket, and we've got 3.3 thousand ohms. So our spec on that is 0 to 10,000, so we're good on that also. So I wouldn't really expect anything different. You know, this is a working coil, came off of my pickup that I drive all the time. So if it was out of spec, I'd probably be a little bit surprised. So we have our spark plug here. This is the one off the cylinder where I had that messed up wire the other day, so it's got some fresh grease on it and everything. These plugs aren't terribly old. These are platinum plugs, so they should last for quite a while. But let me grab my gap gauge if I can find it. So it turns out after looking for a few minutes that I can't find my spark plug gapping tool anywhere in this here toolbox. So we're going to do the next best thing and use feeler gauges. So I do have some feeler gauges. I said earlier our spec on the spark plug gap is 40 thousandths of an inch. So I have a 35 thousandths feeler and a 5 thousandths stacked up, so we'll have 40 thousandths of an inch. So we're going to get that in there. It goes in pretty easy. So this thing does have a little bit of wear on it probably. I said these plugs aren't that old, but they're also not that new either. So they do have a few miles on them. It's not bad enough that I'm really going to mess with it, but I definitely check when you're doing new spark plugs, or if you think you have a problem also. If this thing was a mile wide, then yeah, we'd probably do something with it, but it's off just a little bit. Some other things to note when you're checking spark plugs. Obviously you want to look at your electrodes for any kind of wear, but there's this ceramic insulator up here in the electrode. I've seen those crack and parts of that start to come off, so take a look at that. The other thing that spark plugs can do that I don't recall seeing, it's called carbon tracking. So if you have a misfire and you pull your plugs out, and I'll put a picture of it up here in just a second, you're going to be looking for these heavy black marks that go from the top up here all the way down the side of the porcelain. And if your gap is too big, what will happen is it's easier for the spark to jump from here to here than it is, jumping that gap. And every time it sparks down that insulator, it creates a carbon track. And the more it does it, the easier it is for it to follow that track. So eventually that's just what it's going to do. It's going to follow that line instead of jumping the gap on the other end of the plug. It's not terribly uncommon to find that happen, and it's usually just because the plugs are worn out. But one thing to note, if you do find carbon tracking on a spark plug, look inside the boot, because 99% of the time there will be a matching carbon track inside the boot. And if you replace the plug without replacing the wire, then it's just going to follow that same path in the boot, and you're going to carbon track your new spark plug after a pretty short time. So that's another thing to keep an eye out for. It's not too terribly uncommon, but always check in the boot on the wire, or also if you have coil on plug, the boot in there, because it'll do the same thing. So you may end up needing a whole new coil. But our gap on our plug checks okay. So we'll go ahead and put that thing back in the truck. Our torque on these, it's interesting, they actually give two different torque specs for these spark plugs, and the difference in spec is between new and used heads. So if you have a used head, it's 15 newton meters or 11 foot-pounds, and if it's a new aluminum head, it's going to be 20 newton meters. So they don't have you tighten down as much as if you're putting it in an older cylinder head. So that's our torque spec, is going to be 15 newton meters. And lastly, I believe they want us to ohm out these spark plug wires, so I'm going to go ahead and do that. I still got my meter set up here, and all I'm going to do, I got a gator clip on one side. I'm going to clip onto this electrode, or the terminal on one end. I'm going to take my other and go in here on this side, and I have 896 ohms on this wire. So our spec is 30 thousandths or under, so we're quite a ways under spec. So this is a brand new spark plug wire that I got to replace that broken one from the other day. This is an AC Delco, like a GM OE kind of spark plug wire, versus these other aftermarket ones that were on the truck already from the previous owner. It's kind of curious as to what these old wires ohmed out as. So I did the same thing. I took my gator clip side. Plus I gotta drop everything. I clipped it in the terminal in here. When I come into the other end, I'm getting I don't know if you guys can see my meter or not, but I'm getting having a real hard time getting an accurate reading. I think there might be a little bit of corrosion inside of these, the ends of these wires is giving me a hard time getting a good solid reading on here. But even when it does bounce around all over like that, it's still up in the, there's 1.7, 1.8 thousand. I guess that is that would be within spec, but as this thing's bouncing around, it's hitting 150,000, a million something ohms. If I was to encounter something like this in the field, if I thought maybe I had a problem with wires or what have you, I'd probably just go ahead and replace or recommend a whole set. Sometimes you're going to come across readings that are kind of inconclusive, but in the case of these, it's your resistance measurement is bouncing all over. These look like they got a few miles on them. I'm just going to go ahead and sell them anyways. So that's what I would do in that case. I'm probably going to add wires to the list of things I need to do to my truck, because these things, like I said, I've had this truck probably 7 years or so, and these wires have been on there from the previous owner, so they definitely have a lot of miles on them. So it's one more thing to add to the list. But I didn't find anything wrong with anything. The things that we could tested within specification, so there's not anything we really need to do to this truck to keep it running. So fill these sheets out the best that you can. Like I said, if it's asking about the primary side, things like that, just put NA, or if it's a spec that I didn't give you, you can throw NA in there also. But get these sheets filled out the best as you can, and we'll have a couple more tomorrow. Have a good one.